All right, this is part 2 of quantum numbers. So in the first part A of these two videos, we talked about the principal quantum number, which is describing the amount of energy that the electron has. It also corresponds to how far away from the nucleus the electron is. So we know distance from the nucleus equals or relates to how much energy the electron has. That is not new learning. We looked at that in grade 11. And then we talked about the second quantum number, L, the secondary quantum number, and this describes the shape of the orbital. So the shape of the area of probability we can find the electron. And there's a whole bunch of different shapes, and we are only focusing on when L equals 0 or L equals 1, which would be S and P. The S orbital, when L equals 0, is a sphere. So there's a 1s sphere and a 2s sphere. And there would be a 3s and a 4s and a 5s. They would get progressively bigger, but we're just focusing on 1s and 2s. And then the second shape, when L equals 1, it's a P shape. So L is P, and it is a dumbbell. So P is the dumbbell shape. The third quantum number is a magnetic quantum number. It describes the orientation of the orbital in space because you're looking at a three-dimensional sphere here of the atom. And so the dumbbell can be arranged at a whole bunch of different angles. It could be on this angle or this angle or this angle. So we have to describe the orientation of the dumbbell shape around the nucleus. So when L equals 1, then ML can be 1, 0, or minus 1. What this means is there's three orbitals. They have the same amount of energy because they have the same N. They have the same shape because they're all L equals 1, a P shape, but they differ by orientation. So the magnetic spin or magnetic quantum number, is different. So this picture shows you the three different orientations the dumbbell shape can have. So for example, we're going to pretend we're looking at energy level 2, shape 1, L is 1, and so we have a dumbbell. So when ML is minus 1, then it is on the y-axis. And we're still thinking about the nucleus being in the middle here, the middle right here, where all the axes meet. So that's where our nucleus is. So when the dumbbell shape is kind of like up and down on the y, that is ML minus 1. Now, it can also be the same amount of energy, same distance from the nucleus, same shape, but now it's angled like this. So kind of coming out towards you and back away from you on the z-axis. So that is ML0. And then our last one, P2px, is when you have the same amount of energy because you're the same distance from the nucleus, so you're N2. You have a dumbbell shape, so L1, and ML1. And now your dumbbell shape is oriented this way around the nucleus. So magnetic quantum number is just describing the orientation of the shape in that three-dimensional space of the atom. And you guessed it, if we were looking to look at L equals 2, there is way more different orientations that orbital can have. But that is something for you to look at if you continue into quantum mechanics in post-secondary. The fourth quantum number describes the direction the electron is traveling around the nucleus. And this is called the spin quantum number, or MS, right here. So two electrons can have exactly the same amount of energy, so N, shape L, and orientation ML, but they're spinning in opposite directions. So one of them is spinning clockwise and one of them is spinning counterclockwise. And we use just a plus half and a minus half to indicate that one is spinning clockwise and one is spinning counterclockwise. The spins are equal in magnitude, and this is so they cancel each other out and don't cause magnetic properties. Okay, so those are our four quantum numbers. Principal quantum number, amount of energy, distance from the nucleus, which is basically what we learned in grade 11. Secondary quantum number describes the shape of the orbital, so the shape of the area of probability we can find the electron. Magnetic quantum number describes the orientation that orbital is in three-dimensional space, so the angle. And spin quantum number describes the electron, whether it is spinning clockwise or counterclockwise. Okay. The last thing for this is the Pauli exclusion principle. And this is going to come into play in our next lesson when we talk about electron configuration and electron energy level diagrams. And the Pauli exclusion principle says that no two electrons within an atom can have the same set of 4 quantum numbers. Okay, so that's it. That is a note for quantum numbers for you to copy and get into your notebooks. I would really encourage you to watch the other videos that I am providing as support because they have some really good imaging, some really good graphics to give you a much better understanding of the principal quantum numbers.